Hey everyone. Oh my God. Hopefully it'll be starting here in a second. So it was supposed to begin at 7 and no heads up either. So welcome. Let me know you're here. Yeah. The test ran 499.6 seconds. All right.
Hey, good evening, everybody. So first, what a great day and a great test. And right up front, I just want to say how proud I am of this team. Many of the team members have been on the program for a lot of years, and have worked really hard to get to this point, including the past year during all the challenges we've had with the global pandemic. And I just could not be more proud of the team, of their talent, dedication, getting to this point and pulling off a just very successful test. It's been a really, actually, great year for NASA during a very challenging year for the nation and the world. We had the first launch of astronauts from American soil in almost 10 years with the Demo 2 launch. We followed that up with the Earth Science Mission, the Mike Pilot, 76 Mike Pilot launch, and then the Crew 1 launch, our second crew launch to the International Space Station, and then in February, the Perseverance landing, and now the Green Run test. And so I am so grateful and proud for the NASA team, our industry partners, our academic partners, and our international partners that work together and to pull off these amazing accomplishments. And I am proud and humbled to be a leader of this organization. So, what does this mean for our plans? Well, this is a major milestone in advancing our goals and objectives for Artemis. To land the first woman and the next man on the surface of the moon, and to return to the moon, this time to stay. So it's going to sustainably demonstrate the capabilities and technologies that we need to eventually achieve a human mission to Mars. So not only critical for our Artemis plans, but critical for our overall Moon Mars plan and achieving that ultimate goal. And this test will allow us to continue the integration of this Space Launch System, the largest, most powerful rocket ever developed. We're going to integrate with the Orion spacecraft and do an uncrewed test flight, leading to a crewed test flight and then that first landing mission on the moon. And the SLS and Orion, along with the Gateway and the Human Landing System, the first human-rated landing system in development since Apollo, are the backbone of the systems and the architecture that we're going to need to accomplish these goals and objectives of a permanent and sustaining presence around and on the moon. So this is a major step in advancing our goals. And again, couldn't be more proud of the team. And I just almost speechless about how well things went today. So thank you very much.
All right, we'll go to comments.
Comments. This has just been a tremendous day. Congratulations, John and Julie, your teams, the other teams represented here today, and everybody that worked all those years before today, actually at the design and manufacturing facility. Everything that goes behind a rocket is really an amazing accomplishment. This is the last really big development that we need to do to design this. And our program, we take it a step at a time. This was a really important step for us. John and Julie talked about the next steps in terms of reviewing the data and seeing what we got out of the test. Generally speaking, it's going to take about 10 months to complete the equipment. Then we will ship it down to the Cape. It goes down the Pearl River, through the Gulf, down to Florida, and then Cocoa Beach, and we're doing the turn races. And for those folks that are familiar with the VAB, we actually go into the VAB, and we go to the right at the very end, that's Highway 3, and we're going to put it right in the stack. We've got the boosters ready to go, and we've got processing going in Orion. And I just can't agree with Steve more. A lot of us are going to look back at this day, later in our careers and our lives, talk to our families and friends and others, and say we were here for a very important test, the most powerful rocket ever built. In terms of what happens after this, once we get to the Cape, we'll take it a step at a time. We have a lot of very specific activities that will occur next, stacking operations, integration operations, test and check out. And when we accomplish those operations, we'll be ready to fly. And just as we've done today, we like to take that a step at a time and see how we do later on in the year. We're very excited about that, and it's going to be very visible. We're going to bring everybody along to kind of follow us as we go through the year. And we're very excited about that. So I can turn it over to John. Congratulations, John.
Thanks, Tom. I have to tell you that it was very exciting to see the test today. You know, this was a combination of a series of tests, and I just couldn't be more excited and proud of the team. You know, it's been several years since I experienced the vibration and the sense of the power and the feeling of a rocket like this. And it literally just gives me the cold chills whenever I get to experience that. And I think what it does for the team, it's really it's the fruits of their hard work, and that's extremely important, and that's what keeps driving this team. We've had some challenges with this green run, and I'm just so proud of the team with the way they methodically work through these challenges, and just the work that they've done got us to where we are today and got us to a really good test. All the data that we have looked at so far, we've got a lot more to look at, but everything that we've seen in the test today was phenomenal. So I would say the core stage, Julie got an A+ today. And so I can't go without thanking Julie and the stages team, all the folks in the SLS program, our prime contractors, Boeing and Rocketdyne, and especially our friends at Stennis that provided a great test facility and a great test operations team. I got to see this team go through this series of tests, and the more they tested, the better they got. And that was really evident today, with a good smooth, countdown to get us into the test. I would also just like to take just 1 second of time to mention the fact that we did lose one of our teammates this week, and it was Mike Rudolph. He's one of our forefathers that worked in the program with us, and he will be dearly missed, and we owe him a debt of gratitude for his contributions to get us to where we got to today. As Tom mentioned, we'll be getting on the test stand and assessing the core stage over the next few days, and taking a look at what kind of work we need to do on the stage to get it ready to ship. And then at that point in time, we'll remove it from the stand and get it in the barge and ship it to KSC. We're really looking forward to that. So SLS, we've got all our hardware at KSC. We've got both boosters back, and we're really excited to be able to get the core stage to KSC and get it stacked in between those two boosters. But you out there, what do you think?
So yes, it's been an extraordinary day. So a lot of hard work has gone into getting us to this point today. The team is amazing. Every time we test, we learn something new, and they're so resilient. And the team that pulled together today, the Boeing and Lockheed and the Stennis and the SLS team, we have met several challenges this year, not to mention the COVID, but also with all the weather challenges we had. We actually had a weather challenge last night, actually. So we were watching the bad storms come through. But we had a Stennis team that was on the ready, and they came out around 2 a.m. and got on the facility and finished up all the pre-test work that we needed to do out on the stand. So at 5:30, when the test team came in, we had a all clear sign, and we were ready to go into test. At 6 a.m. this morning, we did our tanking, go, no go, and we had no anomalies, no issues with the work. And that was pretty much the way the whole day went. We went through the whole day. We had no significant anomalies. It was the smoothest test I think that for sure we've ever ran. Several other people on the team said any test they've been part of. I mean, we had no major issues, and we went all the way up to the T-minus 10 minutes, and we did a hold and checked everything, and did the final go, no go from the test team, and went right into the hot fire. So I think you can see from the video and then and everything that all the data we're seeing now, as Mr. Honeycutt said, everything looks like we were right down the middle of our modeling and our analysis. We have met all of our objectives now. So, we talked about we needed at least 4 minutes. Well, we did twice as good as we needed. So, big thanks to the team. And we couldn't be more proud and more humbled to be part of such a fantastic team. There was never a point where somebody said, that's not my job. It was all about what we got to do to get this hot fire off today. So, great effort, and I wanted to just thank everybody.
Thank you. We'll now take questions from reporters on the line. Please press star one to enter into the queue. We ask that you please put one question and identify the email questions directly. If you have time, we'll allow reporters to ask a second question. Again, you can enter star one on your phone to be joined into the queue at any time, and you can enter star two to be removed from the queue. All right, so for our first question, we'll take Marcia Dunn from Associated Press.
Question for Mr. Jurczyk. I'm wondering what kind of schedule you think you have for this year. Do you think you can launch the first flight by year's end, or do you think it'll bump into 2022? And what about the first moon landing? When do you think that might actually take place? Thank you.
Okay, I'm going to take the moon landing part, and I'm going to kick the launch part to Tom Whitmire. Okay, yeah, so on the moon landing part, we have an internal study that we're conducting right now to look at the missions beyond Artemis 2. And particularly given the appropriations that we got in FY21, actually it was a really good appropriations in 21, including a good bit of funding for the landing system, but not what we requested. And so probably take a few months to get through that study. We'll take a look at what we can optimally do given the FY21 budgets and expected budgets in the out years, and lay out the mission manifesting cadence beyond the Artemis 2 mission. So we have some work to do there, but we're in the middle of that work right now.
Okay, let me talk about the launch situation, and it's kind of what I've described to start the process. We take this a step at a time. We saw that here today. I mean, our goal is to get through certain tests and certain activities, and when we're done with that, we have an opportunity to fly. And so I'm always very careful. I use the shuttle program, and we're always very careful to say, we need to get through every one of these tasks, every one of these activities. They're highly visible events. You'll be able to follow the hardware as it comes from here, travels down to the Cape, is integrated in the Cape. We're already processing line. We're loading line with fuel. We're already have the booster stack ready to go. And so the real answer to your question is when we complete those tests, then we'll be in position to fly. Now, like we saw here at Stennis, these tests were really important. We did learn some new things as we went through that. I think it was a tremendous accomplishment as if for the first time flight.
It'll fly next year.
We really learned some important things. And so I expect we'll learn some important things when we get down to Florida. It'll be the first time we've used the facilities in Florida. We may come across a few things that we need to address. So I think the real answer to your question is that, we're looking for opportunities this year, but the real answer is we will absolutely keep you advised of how we're doing throughout the process. We'll let you know what the progress looks like. They're all highly visible events, the individual integration tasks that are easy to follow. And as we get the vehicle to the Cape, we'll be able to provide additional information about the process flow looks like at the Cape. And that's the real answer to the question.
Thank you. Our next question is from Irene Fox of Aviation Week.
My question is for Steve. Could you describe what sort of interactions you've had with the Biden administration, and if you've gotten any indications of how things might be different in the NASA program, part of this in particular, but anything else in general that you could see shifting? Thank you.
Yeah, so in general, we've gotten really good support from the Biden administration, pretty much across the board. I have to say I am optimistic about the trajectory that we're and sort of staying on that trajectory. Now, with respect to Artemis, I was really excited and glad to see early on the administration communicated their support for the goals and objectives of the Artemis program and our overall Moon to Mars strategy. And obviously, human exploration is human missions, human spaceflight missions are the most complex and visible aspect of Artemis, but we also are conducting robotic missions to the Moon and to Mars. The robotic Mars missions are also part of the planning and advancing our goals and objectives to Moon and Mars, as well as technology and demonstrating technologies that are going to allow us to stay on the Moon sustainably and for the long term and enable human missions to Mars. So the administration has really embraced our overall Artemis strategy and goals and objectives, and so far we've supported that, as well as highlighted other ways in which we contribute to important policy objectives for the new administration, including climate change, that includes the research that we do with our satellites and instruments, reducing the environmental impact of aviation, STEM engagement. That's really important. One of the important things we do is inspire the next generation and inspire our youth to go into science, technology, engineering, and math, and using the power of diversity and inclusion to advance our goals and solve the really tough problems that we have. So far, I am really excited about the support we've gotten from the Biden administration.
Thank you. Our next question is from Philip Sloss of NASASpaceflight.com.
Yeah, I think this is for Julie Bassler or John Shannon. It sounded like on the audio that you got the low-level cutoff test, the lock completion test, but I just wanted to check and see, confirm that you did. And anything you can talk about in terms of the process from here to putting the stage on the barge. Thanks.
Yeah, so this, I'll take that part of that. I'm not familiar, Philip, with any, low-level cutoff.
We have a plan, we will low level off the cut.
Okay, yes, okay, so, yeah. Okay, yes, we did meet that objective, okay, now I'm with you. And as far as, finishing up, what we have left to do, so we'll be doing our refurbishments, we'll be reviewing data, and then we'll do our breaker configuration. And then we have, about mid-April is what we're targeting right now to do, shipping our, core stage over on the barge to KSC. And so by the end of April, we're looking at arriving at KSC. John Shannon, I'll throw it over to you if you want to add anything.
Julie, that was a great explanation. Philip, from our initial look at all the data, we achieved all of the objectives, even our secondary objectives. We did see a rocks low-level cutoff. And the system behaved exactly as it should. And so we're very excited about the data that we've gotten, terabytes. We'll be working through that over the next couple of weeks as we do very detailed inspections of the hardware. But the initial look is that everything worked perfectly. And we also can't forget to say that it wasn't just the vehicle that worked perfectly today, it was the B2 test stand. And the work that the Stennis Space Center did to pull off an amazing test like this was unbelievable. All of their systems just worked exactly like they should.
Thank you. Our next question is from Eric Berger of Ars Technica.
Congratulations, everyone. Looked great today. The engine fire, the core installation fire, it seemed like that was expected because of the hot exhaust on the test stand, and I think some of that was planned for. Can someone, maybe John Honeycutt or John Shannon, talk about kind of what we saw there on the screen and why that probably wouldn't be an issue in flight in a different environment? Thank you.
Yeah, Eric, I'll tell you what I know a little bit about it. I'm not a thermal expert by any means, but, after the first test, we saw some base heating data that made us look at the amount of quick insulation that we had in the bugtail area of the engine section. Team went off and made a decision, number one, to go ahead and remove those rain covers that were on the engine blankets, and we saw those burn off in the previous test. Number two was to add some cork insulation and some of the reflective tape, and we did that. I would guess that's something on the order of probably 4 or 5 inches of cork in layers applied with adhesive. So what you saw there was some of the tape burning off, as well as once one of the layers of cork got ablated, then you see the adhesive burn. We don't expect to see that during flight. Just due to the environments are different, and the acting of the vehicle will experience that same radiative heat mode. Mr. Shannon or Julie, if I missed anything there,
Yeah, I think you covered it exactly correctly, Mr. Hennigan. John Shannon, do you have anything to add?
I would just add one thing. While it looked kind of interesting, 2 points. One is we have temperature sensors underneath that cork, and none of those sensors got above 100 degrees, so we were in great shape. The cork did its job. And as John said, after 2 minutes of flight, we're out of the sensible atmosphere, and you wouldn't have it burning like that. So you guys got it exactly right.
All right, thank you. Our next question is from Stephen Clark of Spaceflight Now.
Hi, can you hear me?
Yes, we can hear you.
Hi, this is Stephen Clark from Spaceflight Now. Just wanted to ask about the gimbal profile. I know what the gimbal profile toward the end of the burn did, sort of stress the system with, I think, low pressure in the hydraulic system as the fuel tanks, so propellant tanks were getting lower. How did that perform compared to expectations? And also, have you noticed any damage to the foam insulation? Have you had a chance to look at that to see what might
Hello.
have to be touched up after shipment? Thanks.
Yeah, sure.
So yes, the gimbaling that we did and all the actually wrapped up and down and the engine top throttle.
Everyone, I gotta
all
step
that's
away for a
exactly
second.
What we predicted. So right now, the team will go through and look at all that data. But we saw nothing anomalous there, so it was really smooth. From the data that we do have, we're gonna have to go through that thoroughly. But it is looking like we have a very strong TVC system, and we hit all the edges of the boundaries. We were testing the limits there to make sure that we could apply to any kind of environment. And since this is a generational vehicle, it's something we wanted to test for future stages and missions also. And could you repeat the second question again?
Actually, Stephen, he was close to his mic, so Stephen, if you have a question, you can rejoin the queue. All right, our next question is from Will Robinson Smith from WAAY TV.
Hey everyone, congratulations on the test today. I was curious, since the goal, of course, was previously to reach the 4-minute mark, with the ideal being the 8-minute. Can you talk about what some of the important data that was gathered during that 4-minute interval beyond the 4-minute threshold? Thank you.
So I'll address that, and then I'll turn it over to John Shannon too. Really what we were looking for to get past the 4-minute mark was some of our secondary objectives, and that was the frequency response test. That was a good one test that we did. And also looking at when we throttled the engine up and down, that we could withstand those different loads. John Shannon, do you want to add anything to that one?
I'd just say that we collected a lot of data today. Being able to see the hydraulic system work with very little propellant in the tanks with some aggressive gimbaling was a real stress test for the vehicle. And it just gives us great confidence that the vehicle as designed can handle exactly what it's designed for. The vehicle really performed like a champ.
Thank you. Our next question is from Jake Robbins of Lead Martians, and then we'll go to Stephen Clark.
Hey there, congratulations on your test today. It's really great to see. I know you're not going to be green running another SLS core stage, but I think you will be doing one for the exploration upper stage. And my question is, are there any lessons that you learned from this test today that you want to take forward to the US?
Yeah, there's definitely lessons learned there. I think we've learned how to work together as a team and integrate the flight hardware into the test stand. The team's in much better shape, just understanding how the stand operates. We've got some lessons that we learned relative to the things that we need to do relative to how we integrate the EUS into the B1 stand. So I think we got an opportunity to take our lessons learned and really take advantage of the next 3 months test we're going to be doing the exploration stage.
All right, thank you. And we'll go back to Stephen Clark of Spaceflight Now.
Thanks, Stephen Clark, Spaceflight Now. Just wanted to see if you had any chance to do any sort of inspections of the foam or any of the insulation on the outside of the core stage since the hot fire was completed. Any significant notes there on what needs to be touched up or repaired before flight? Thanks.
Yes, so we did notice a couple places in the intertank area, which is the structural piece in between the liquid oxygen tank and, liquid hydrogen tank after, the tanking test and the first hot powder that we did. We went and did some core type repairs to that TPS, and we'll have to do some more work to dress those up, either prior to shipping to KSC, or once it gets to KSC. There, I will say this just overall, I'm super excited about how well the TPS team performed over the last several years. We went through a development process, with new materials. They just did an outstanding job, and the performance of the TPS has just been outstanding. None of us expected that we would be in this good shape coming out of this test. So, I'm really happy.
All right, thank you. Those are actually all the questions that we have, so we'll conclude the Q&A portion. Space Launch System is the only rocket that can send the Orion spacecraft, astronauts, and supplies safely beyond the moon in one launch. The next time these engines fire up, they're on the launch pad, and then uncrewed Orion spacecraft around the moon on a flight test for the Artemis 1 mission. To learn more about NASA's Artemis program, follow our project at nasa.gov/Artemis program.
You good? We don't need any more of these.
And good afternoon and welcome to the Stennis Space Center in southern Mississippi, where NASA spaceflight is live and on the ground with both Philip Sloss and Brady Keniston for the second go at the Green Run hot fire test of the SLS core stage for the Artemis 1 mission and the overall Artemis project. My name is Chris Gephardt. I am the assistant managing editor here at NASA Spaceflight, and I am joined today by, now wait for it folks, because the universe doesn't like it when we're on the stream together, but it's the other Chris. Other Chris, how are you doing?
I'm doing well. How could we not have us both on during an hour 25 test? It's got to be it's got to be a shuttle situation here. So yeah, I am very excited about this because this is literally 4 hours 25 firing up, and hopefully this time we'll get the full duration. Because without the full duration, it doesn't pass the Green Run and it can't proceed core shipping to KSC. So all fingers crossed for this one.
Yes, indeed, and I think yes, Michael.
Yeah, this is Michael. The I'm running it back in today, but I do have to interrupt the live stream. I'm sorry, everyone. It would not be a NASA spaceflight live stream if we did not get Starship on the stream in some degree. And we have breaking news from Boca Chica right now. They are about to stack the first ever Super Heavy booster. So I know we have an important SLS test today, but we will obviously show this as it happens as well.
Gotcha, indeed. And yes, that was my
isn't it? It seems up that Michael interrupts me. Whenever something's going on in Boca Chica, I get interrupted by Michael because there's always something going on. I'm usually speaking when it's happening. So, yeah, this is hilarious because we're seeing two monster rockets, the next two monster rockets, NASA's SLS, being tested while SpaceX are about to stack the first super heavy booster. These are the two what we call super heavy launch vehicles, HLV. So this is really amazing timing for this both to be happening. It's not on purpose, guys. Trust me, it's not SpaceX trolling SLS or anything like that. This is just the way the worlds collide.
Indeed, indeed, because like we've said many, many times, right? Like, you know, these two ongoing test programs, they are very, very different, but they're both very, very vital to what the U.S. space aspirations and goals are for the immediate and long-term future. So yeah, on your left, you have a super heavy booster from SpaceX being stacked. You have the nose cone simulator or mock-up for the version of the moon ship for the Artemis program. So on the right, you have the core stage of the rocket that will be integral in launching those crew members for the Artemis program as well. So yeah, as we are counting down here for that particular green run, Hotfire again, we have Brady Kenniston on the ground as well as our own Philip Sloss, who's busy interviewing people. So we're not sure he's going to be on the stream commentating, but he's busy interviewing folks down there for a bunch of articles and follow-up stuff that we have after the green run is over and complete. Because as Chris, as you were mentioning, hopefully this is a full duration Hotfire. We'll get to what that means in a minute because there are a couple definitions you could go by. But yeah, hopefully it meets their minimum set of test requirements to get the data that they need to ship this core stage to Kennedy, because that's really the big milestone after this is getting it shipped to Kennedy to get it stacked with those boosters. Which I don't know about you, Chris, but man, seeing a full stack, a complete stack of twin solid rocket boosters brought back nice memories.
Yeah, I've just tweeted what a time to be alive, because we've just seen Super Heavy BM1 about to stack as Artemis, one SLS course stage is about to fire up. This is what we've been waiting for. We both remember the end of Shuttle, and sure, there was constellation and things like that. It wasn't as the mass media portrayed it to be the end of spaceflight, the end of NASA. It never was, but it certainly was an uncertain time, an uncertain period, and we never. I mean, in Ares 5 with the constellation program, that's the nearest thing to SLS, but that was a long way away. We had Ares 1, and now that's about it. There's a few commercial companies coming up into the rise. SpaceX was starting off, really, they were in their early days. They were not really anywhere close to what we're looking at now with the Starship program. They were looking at just normal satellite launching rockets and potential of crew launch later. We're now way past that now. We're into this stage of seeing these huge rockets that will take us beyond Earth orbit. That is the key there. Ever since even including Shuttle, we were restricted from the Saturn V days where we were going to the moon. We were restricted to low Earth orbit. And now we're in the potential of two vehicles that could potentially launch people to beyond Earth orbit and beyond to Mars. And we're watching it now. We're watching the baby steps. We're watching the early stages of this program for both SpaceX Commercial and NASA as an agency going forward with this, and at the same time.
Yeah.
I don't know if you just saw that, but I accidentally showed NASA feed because they were showing an amazing drone shot and then they switched to a host. If you watched the NASA feed of the green run, the official NASA feed of the green run last time, you will note they like to have a lot of hosts talking and not a lot of rockets. So on our broadcast today, we plan to show a shot of Stennis the entire time unless we get interrupted by Starship. But of course, once we get to the business end of the countdown for SLS, we will have the test stand at Stennis on the screen the entire time. And we will also bring in NASA broadcast with their views of the test stand as well. So, long story short, sure we will have all the best camera angles on our broadcast, and we will not put toast on the screen. Everyone wants to see the rocket. You don't want to see people talk.
It's quite funny during the NASA TV feed the first time it run, they were literally just showing endless Zoom chats. There was a reason for that. It was funny to see, but the reason they were doing it is because, and we're seeing the polar opposites here, and that's why I want to bring it up. We're seeing NASA promote the fact that they have thousands of employees and contractors and companies involved across the states, which is why it costs so much money. But that is a bonus to them because that plays into the old lawmaker situation. It gets them the funding they want because every district says, "Oh, we've got some workers involved in this. We're not going to vote against SLS anyway. We've won the jobs." Unfortunately, that's why it gets a job title for sort of like slight at it. But at the same time, you can understand that's a good thing. That is good jobs being involved in building rockets. It's a good thing, and that's why they promote it. Whereas SpaceX go for the low cost and go internal and do everything in-house as such. And they play on that. They say, well, this is why we can do things faster. We can do things cheaper because we've got everything sourced at our own base to build this Boca Chica launch site and production site in no time at a fraction of the cost compared to anywhere else, like ULA or anyone like that. So that's where the polar rockets are involved. But the beauty is that with the two things working in parallel, we may have a situation in the mid-2020s, maybe the 2030s, where both of these rockets are working together. And that will get us to Mars faster. So that is a key thing there. With the government support and the commercial drive, these two things could work out and could be actual stablemates going forward.
You're taking some shots there of the NASA drone footage of the test stand at Stennis Space Center. And hopefully, the latest information we have, I think, is from Eric Berger, who said they were targeting between 3 p.m. Central Time and 3:15 p.m. Central Time. So hopefully, just a couple of minutes away from the business end of the countdown. We'll have to see how this is going to play out.
Gotcha. And what I love about this drone footage is you can see some of the propellant barges that Stennis uses. There to help fuel the SLS vehicle and keep it firmly replenished with, not firmly, fully replenished. There we go, that's the right word. Fully replenished with its liquid oxygen and liquid hydrogen as it goes through its thermal conditioning and its simulated countdown as it would if it were sitting on the launch pad at the Kennedy Space Center. But as always, it's not just about us talking here at NASA Spaceflight, although you have two Chris's on the stream, so if you ask a shuttle question, all bets are off that there'll be another one answered for the engine's fire. Yeah, if you do have any questions, please tag us at NASA Spaceflight in chat. Tagging us that way puts the question, makes it more visible to us in a special program that Michael has written, and we can more easily see it and get it entered into the queue. And we will do our best to answer the questions that are asked. However, we always have way more questions asked, which we love, but unfortunately way more questions asked than we can answer. So sometimes it might take us a little while to get to your questions too, but we will do our very best. And right off the bat here, I wanted to read a couple of super chats. The Mosh Pit God with $10 saying Orange Rocket good. I think that's a great super chat to begin the day with. Yes, indeed, Orange Rocket good. Another one from Cassie W, $5 saying hi from Joss and Cassie, all about the rocket love. We agree, all about the rocket love all around. CMP Railroad with $5. SpaceX, how could you make us decide which one to watch? Well, the good part is you don't have to decide which one to watch because if they start doing something with the Super Heavy booster, we'll bring it to you right here as we're on the air for this weekend as well.
We're going to focus on the SLS hot fire.
Yes.
Well, nothing's happening with Super Heavy. So right now we saw the crane was hooked up. I can go back just for a second. But we're not seeing any lifting yet. So if they start lifting, rest assured you will jump to Super Heavy.
But of course, you know, we are here first and foremost for the SLS hot fire. What you are now seeing is the control center at Stennis, where teams are monitoring the core stage and all of the parameters there as they head toward a targeted T0 here, coming up roughly a little more than an hour from now. I think soon, much sooner than that. I'm sorry, I got my time zones mixed up. Yeah, with a hot fire coming here shortly. expected within about half an hour or so. So let's keep going with some of the super chats here and some of our questions. Great question here from Michael. So can the steams from the engine exhaust trigger lightning? Excellent question. So not really in this regard. You are correct. It's just steam. It's water vapor is the exhaust from the engines. It burns hydrogen and oxygen, so it's very clear. It can rain, and if atmospheric conditions are correct, it could trigger lightning. But if those conditions were present at the test site, they wouldn't be firing up the engines to begin with, because they would need to be protecting the equipment and not trying to trigger lightning in that regard. So technically possible, but they wouldn't be testing in that type of a configuration if it were. This is actually a great shot. Look at that of all four of them. Thermal blankets.
I don't get that. They go to the video, so I go back to our camera. But,
No. I agree. Yes. All good.
Can I just mention, Chris, the beauty of those engines? They are all shuttle veterans.
I know, right?
They have all flown. Now, that's the big debate in the community. The debate between, would you rather see those four engines which have flown a shuttle in a museum, or would you rather see them go out in one blaze of glory and be on the bottom of the ocean? It's a tough one. Personally, I'm in the camp of using them one final time. Everyone would like them to be reusable, as they were designed to be and work on shuttle, but of course, SLS is not reusable. So, one fire. In fact, last chat, what's your thoughts? These RS-25s that have flown a shuttle in a museum, or fly one more time? Let's see what people say. I'm all knowing the moderators. Most people would say museum.
Yeah. I don't know.
So,
It's a hard
yeah, the
call.
community say museum.
So here's a good question from Matthew with a £5 super chat asking, why is there such a mammoth setup here for what is ultimately a static fire? Are SpaceX just better at testing than NASA? So no, it's not that they're better than testing, it's that the testing requirements are different. So SpaceX is able to build their test stands for the rocket that they have, whereas the test stands that you see at Stennis are capable of handling multiple different vehicles, right? So you have to have more of a structure that can handle different commodities here and there, different thrust levels, different types of vehicles that are being tested, because it's not just the SLS, it's not just the RS-25 engines that the SLS uses. There's also the engines for the Delta IV Heavy that are coming through, Relativity, Firefly are there as well. A bunch of companies actually use the grounds of Stennis for testing and acceptance. So what NASA actually did was build a multi-user engine and rocket test facility that people could use if they wanted to, or that different companies could use if they wanted to. So it's just a different design. And specifically, they were doing this back in the 1960s. So what you're looking at here are some of the original stands that were used for the acceptance testing and firing of the Saturn V stages, the Saturn IV stages, the Saturn 1B stages that were used throughout the Apollo program. And then they were converted and used for shuttle, and then they were converted and used for various other organizations and entities throughout the years. So it just so happens that the SLS core stage is what's on there now. There are those engines again. And you can see the gray nozzles protruding down from those white little cones that cover them. Those are the thermal protection system blankets. And everything. Well, here's a good thing about the RS-25s, which confusingly begins with an image of Hubble. And a Mercury Redstone Atlas. Okay. I'm not sure the history behind. Okay, there we go. Okay. I was gonna say I'm not sure what we're showing there, but or what NASA was showing there, but that was definitely the NASA feed. Yes.
Like I mentioned, the NASA feed has a bunch of random B-roll videos and hosting content. So we'll keep our cameras on the test stand. Thanks to Brady, who has set up this camera at the media viewing place, and he's got this great shot of the test stand. And hopefully, as we get closer to the test itself, NASA will focus their coverage on the actual test stand itself, not B-roll videos.
And Michael, have they said on their stream what the target time is?
No, they're
Or are
just
they
talking about engine history and what the Artemis program is, and nothing directly related to the actual test status.
Okay, gotcha. So we're still standing by for that specific time there. So yeah, so Casey Edwards with a 10-pound super chat saying, "Go Team Space! Cheers to all that you do at the NASA Spaceflight team. Feels like there's so much going on in the space industry for this generation to really get excited about." I agree. That's a great way to put it too. There is a tremendous amount to be majorly excited about. Indeed. Taylor Vanderkamp with $5. Love these streams always. Keep up the good work. In this particular test, the thrust is 4. Yes, the thrust is 4. Doug Krause with $5 saying rockets are good. We agree. Here's a good question, Chris. Comes from Mr. Toxic Hot Dog.
Okay. I am sorry, everyone. If anyone is still here, which probably they aren't. Yeah. So I don't know if anyone is still here, but I'll leave it on here since I was gone for as long as I did. And it ends up she lives here. She just bought a unit, but she never said anything. Literally bought the unit at auction today and decided to use the dumpster. But it is what it is, all right? So, but they did bust the fence. So that was the big deal. As they were trying to get out because they were getting caught. But it is what it is. So everyone have a good one. Peace out.